Good day, everyone. I'm Sir RJ Leeson, your math tutor and guide on this exciting journey through the world of numbers. In this video, we will discuss all about zero and negative integral exponents. Before we proceed to the zero and negative exponent lesson, let us recall first what are the laws of exponents, because this is very important in tackling the zero and negative integral exponents. So we have here, let a and b be any number of and m and n may be any positive integers. The product rule we have here, a raised to m times a raised to n. So if you have the same base, you just need to add the exponent. So we have here a raised to m plus n. In the quotient rule, if you have the same base also, we have a sub m over a sub n, you just need to subtract the exponent. So copy the base if you have the same base. So then subtract m minus n. Raising a power to a power rule. So if you have here an exponent variable raised to another power, you just need to multiply the exponent. So we have here a raised to m raised to n, so you just need to multiply the exponent. So you have here a raised to m times n. Raising a product to a power rule. So we have here in the raising a product to a power rule, we have two or more variables here. So a and b raised to m, you just need to distribute the exponent there. So you have here a raised to m times b raised to m. Raising a quotient to a power rule, same way here. If you have a numerator and denominator you raise to a power, you just need to distribute the exponent to the numerator and denominator. So you will get a raised to m over b raised to m. Okay, for us to recall more about laws of exponent, let's have an example in each laws. So for the product rule, we have here, if you have x raised to 2 times x raised to 5, since you have the same base x, you just need to add the exponent 2 plus 5, we have x raised to 7. Number 2, we have y raised to 5 times y raised to 15. So since you have the same base y, you just add the exponents 15 plus 5, so we have y raised to 20. 2 raised to 2 times 2 raised to 3. So you just need to add the exponent 2 raised to 2 plus 3. We have 2 raised to 5. To simplify 2 raised to 5, 2 times 2 times 2 times 2 times 2, we have 32. Quotient rule. So if you have the same base, you just need to subtract the exponent. So we have c raised to 5 over c raised to 3 equals to c raised to 5 minus 3. So we have c raised to 2. Example 2, we have z raised to 15 over z raised to 9 equals z raised to 15 minus 9. So we have z raised to 6. Example 3, 3 raised to 5, divide 3 raised to 2. So we have 3 raised to 5 minus 2. So we have now 3 raised to 3. So 3 times 3 times 3, we have 27. Raising a power to a power rule. So we have here, if you have an exponent raised to another exponent, you just need to multiply them. So example number 1, b raised to 2 raised to 3. So we have b raised to 2 times 3. So we have b raised to 6. Example number 2, y raised to 5 raised to 4. We have y raised to 5 times 4. We have y raised to 20. 3 raised to 2 raised to 3. We have 3 raised to 2 times 3. We have 3 raised to 6. 3 times 3 times 3 times 3 times 3 times 3. We have 7 to 9. We have raising a product to a power rule. So in here, if you have 2 or more variables no raised to an exponent, you just need to distribute it in each variable. So we have example number 1, x y raised to 5. So you just need distribute to exponent 5 to x and exponent y 5 to y. So we have x raised to 5 and y raised to 5. Next, we have 3ab raised to 3. So distribute the exponent 3. So we have 3 raised to 3, a raised to 3, and b raised to 3. 3 raised to 3 is 27. So we have the answer here, 27, a raised to 3, b raised to 3. Example 3, we have 4yz raised to 4. So distribute the exponent 4 raised to 4, y raised to 4, and z raised to 4. 4 raised to 4 is 256 or 256. So we have the answer 256, y raised to 4, z raised to 4. Raising a quotient to the power rule. So same here. If you have a numerator and denominator, you just need to distribute the exponent here. X over y raised to 3. So we have here x raised to 3 over y raised to 3. 2a over b raised to 2. So we have 2a raised to 2 over b raised to 2. So 2 raised to 2 is 4 and a raised to 2 is a raised to 2. So we have the numerator 4a squared and the denominator we have b squared. So 4a squared over b squared. Example number 3, z over 5 raised to 4. So we have z raised to 4 over 5 raised to 4. So 5 raised to 4 is 625. So that means we have here z raised to 4 over 625. Now let's proceed to zero exponent. So in zero exponent, if you have any variable raised to 0, that means your answer always is equal to 1. Where your a must not equal to 0. Any number excluding 0 with an exponent of 0 is equal to 0. Even if you raise 1 million to 0, it will result into 1. Okay, again, any number or any variable raised to 0, the result is 1. Okay, so let's have an example. So 10 raised to 0, okay, diretso na is 1. 2 over 3 raised to 0, again, it's equal to 1, is equal to 1. 20z raised to 0, since you look at here in example number 3. So since z is the only raised to 0, that means 20 is not included in raising 0. Unless you will have a parenthesis 20z parenthesis raised to 0. So that means all of them will result to 1. So since here in example number 3, 20z raised to 0, so that means 20 is remain 20 and z raised to 0 is 1. So that means 20 times 1, we have 20. So 100, as I said earlier, so if you have a parenthesis, all of the you use parenthesis in all variable and then raised to 0, that means all of them will result to 1. So 100b raised to 0, so you just need to distribute the exponent 100 raised to 0, b raised to 0. We have here 1 times 1 is equal to 1. We have here 15 raised to 0 plus 150 raised to 0 plus 75 raised to 0. So 15 raised to 0 is 1 plus 150 raised to 0 is 1. 75 raised to 0 is 1. So we have 1 plus 1 plus 1, we have 3. And then last example, 25 raised to 0 plus 170 raised to 0 minus 105 raised to 0. So we have 1 plus 1 minus 1. So we have 2. Zero exponent is now into negative exponent. Now class, if you have a negative exponent, for example, a raised to negative n, you just need to change that one into 1 over a raised to n, where your a is not equal to 0 and n is a counting number. Again, if you have a negative exponent, a raised to negative n, you just need to change it into 1 over a raised to positive n. That is the rule of the negative exponent. Let's have an example. 5 raised to negative 2. So we have 1 over, you change into 5 raised to positive 2. So simplify the denominator, you will get 1 over 25. Another example, we have 3 over 4 raised to negative 2. So you just change that one into 1 over 3 raised to 4, 3 over 4 raised to positive 2 now. So you just need to simplify the denominator. So by the raising quotient raising to a power, so 3 raised to 2 is 9, 4 raised to 2 is 16, so we have 1 over 9 over 16. Now class, to simplify this one, you just need to multiply the denominator by its numerator, but the denominator must be the reciprocal of it. So for example, we have 9 over 16, the reciprocal of 9 over 16 is 16 over 9. So just need to multiply 1 times the reciprocal of 9 over 16, that is 16 over 9. So 1 times 16 over 9, so we have 16 over 9. Okay. So next example, we have 10 raised to negative 5 over 10 raised to negative 3. So quotient rule class, if you have the same base, you just need to subtract the exponent. 10 raised to negative 5 minus negative 3. So since we have minus the operation here minus, and then the integer is negative, you just need to change that one into positive. So 10 raised to negative 5 plus 3. So we have 10 raised to negative 2. Okay, negative integral exponent. So we have 1 over 10 raised to 2. So 10 raised to 2 is 100. So we have 1 over 100. Okay, next example, we have 25 times 5 raised to negative 2. So you just need to remain the 25 there and then change the negative exponent. You simplify 1 over 5 raised to 2. So we have 25 times 1 over 25. So that is 25 over 25. So that means you have 1. Okay. So simplify the following and write your answer with the positive exponent. So we have x raised to 9 times x raised to 5. So you just need to add the exponent since we have the same base. X raised to negative 9 plus 5. So we have x raised to negative 4. So we have here 1 over x raised to 4. Okay, example B, we have 4x raised to negative 3 times negative 3x raised to negative 3. So distributive property, so we have 4 times direct multiplication, sorry. So 4 times negative 3, so negative 12. So x raised to 3 times x raised to negative 3. So we have the same base, you just need to add negative 3 plus negative 3. So we have negative 12 x raised to negative 6. So we have negative 12 times negative exponent of x raised to 6. So we have x raised to negative 6. So we have 1 over x raised to 6. So 12 times 1, we have negative 12 times 1, we have 1. Negative 12, sorry. And then 1 over x raised to 6. So we have positive x raised to 6. So we have negative 12 over x raised to 6. Letter C, we have 15 y raised to 0 minus 12 a raised to 0. So simplify this one. So we have 15 times 1 since y raised to 0 is 1. And then minus 12 a raised to 0 is 1. So we have 15 times 1, 15. Minus 12 times 1, 12. So we have 15 minus 12. We have 3. Next, we have 3a squared b raised to negative 3 raised to 5. So you just need to distribute the exponent here. So 3 raised to 5 times a raised to 2 times 5 and b raised to negative 3 times 5. So 3 raised to 5 is 243 and a raised to 2 times 5 is a raised to 10. And b raised to negative 3 times 5, we have b raised to negative 15. Since b raised to negative 15 is a negative exponent, so you just need to simplify this one. So we have 243a raised to 10 times the negative exponent of this one, 1 over b raised to 15. So 243a raised to 10 times 1, we have 243a raised to 10 over b raised to 15. Example letter E. So we have here negative 7 a raised to negative 2 b raised to negative 1 and then all of them raised to negative 2. Since the exponent here is negative 2 na, you can simplify the negative exponent in this one. So we have 1 over negative 7a raised to negative 2, b raised to negative 1 raised to 2. And then simplify this one. So negative 7 squared, distribute the 2 here. So negative 7 squared, negative 7 times negative 7 is positive 49. A raised to negative 2 times 2, we have a raised to negative 4. B raised to negative 1 times 2, we have b raised to negative 2. Okay? So, we have here now 1 over 49. The negative exponent of this one is 1 over a raised to 4. B raised to negative 2, the negative exponent is 1 over b raised to 2. And then, now we have 1 over 49 times 1 times 1, we have 49. A raised to 4 times b raised to 2, we have a raised to 4 times b raised to 2. Okay, to simplify, how to simplify again this one? You just need to change the operation into multiplication, and the denominator, you just need to reciprocal it. So, we have a raised to 4 times b raised to 2 now as our numerator, and our denominator is 49. So that means the answer here is a raised to 4, b raised to 2 over 49. Okay. Simplify the following and write each expression with positive exponents only. So we have a raised to 5, a raised to negative 5 over b raised to negative 9. So simplify this one. So we have 1 over a raised to 5 over 1 over b raised to 9. How to simplify this one? If you have a fraction na denominator, you just need to change the operation division to multiplication. Copy the numerator 1 over a raised to 5, and then you just need to multiply the reciprocal of 1 over b raised to 9. So we have 1 over a raised to 5 times b raised to 9 over 1. So we have now b raised to 9 over a raised to 5. Actually, you can just simply direct you just need to simply simplify this one, the number one problem, no? And you just need to reciprocal and then change the exponent to positive. So, no? You just need to observe, no? You don't need to highlight this one actually. Okay? But then we need to have a step by step in this one so you can learn. So try to observe na lang. Example number 2, we have 7x raised to negative 8 over 8y raised to negative 3. So simplify this one. Change the negative exponent. We have 7. So you just need to remain 7 here since the negative exponent is just x lang. So 1 over x raised to 8 over 8, copy 8, multiplied by the negative exponent of y raised to negative 3. So we have 1 over y raised to 3. So simplify this one. So we have 7 over x raised to 8. And then you just need to multiply this one by the reciprocal of 8 over y raised to 3. So we have y raised to 3 over 8. Now, multiply, direct multiplication. 7 times y raised to 3, we have 7y raised to 3. And x raised to 8 times 8, we have 8x raised to 8. Last example, we have c raised to negative 3, d raised to 5, and over c raised to negative 6 times d raised to 3. So, since we have the same base, so you just need to subtract since it's quotient rule. So we have c minus negative 3 minus 6, then minus negative 6. So we have here negative 6. Okay, sorry. So we have now here c raised to negative 3 minus negative 6 and d raised to 5 minus 3. Okay. Now, since we have here a subtraction operation and a negative, we will change that one into positive. So, we have c raised to negative 3 plus 6, d raised to 5 minus 3. So, simplify, we have c raised to 3 and d raised to 2. Again, thank you so much for watching, and I hope that you've learned something in this lesson. So, please don't forget to like and subscribe to my YouTube channel and share it with your friends, grade 9 student friends. Thank you so much, and God bless everyone. Bye bye.